Students, today's topic is moving coil galvanometer. Basically, galvanometers are of two types. One is pivoted type and one is suspended type. So, suspended type galvanometer is also called moving coil galvanometer. A moving coil galvanometer is basically used to detect the presence of current in a circuit. Working principle of moving coil galvanometer is a current carrying coil suspended in uniform magnetic field experiences torque. Now we come to the construction. A galvanometer consists of a rectangular coil PQST suspended with the help of a phosphor bronze strip from a torsion head. The other end of the coil is connected to a spring. T1 and T2 are two connection screws. The coil consists of insulated copper wires by winding on non-magnetic frame. The coil is suspended symmetrically in between the pole pieces, and the pole pieces are taken to be concave. The pole pieces of the permanent magnet are taken to be concave so that magnetic field is radial. Radial magnetic field is that magnetic field in which for every position of the coil, magnetic field is parallel to the plane of coil. Now we come to working. When current is passed by connecting the galvanometer in the circuit, then the rectangular coil PQST will experience a torque that is tau is equal to NBIA sin theta. Students, we have made the magnetic field radial. Since magnetic field is made radial, theta is equal to 90 degree. That's why tau is equal to NBIA. Actually, tau is equal to NBIA sin theta, but theta is taken 90 degree, so it will become NBIA. Due to this torque, the coil will rotate. Say the coil rotates through an angle alpha. Due to the rotation of the coil, the spring and the phosphor bronze strip will also be get twisted. Due to twist in the spring, it will apply a restoring torque on the coil. The restoring torque is given by K alpha, where K is torsion constant. Torsion constant is the constant, or you can say torque, required to bring the coil back by 1 degree. The torque required to bring the coil back by 1 degree is called torsion constant. If the coil is in equilibrium, the deflecting torque and the restoring torque will be equal. That is NBIA equal to K alpha, or we can say I is equal to K upon NBA upon alpha. K upon NBA is constant for a galvanometer, and that constant is called galvanometer constant. The value of galvanometer constant is different for different galvanometers. Therefore, I is equal to C into alpha, or you can say I is proportional to alpha. If the deflection in the galvanometer is increasing, its meaning is that current is also increasing. Students, remember one thing. In numericals, if you are going to use this formula, I is equal to K upon NBA into alpha, then here alpha will be taken in degree. Don't convert alpha into radian. If alpha is given to you 15 degree, then you will use the value of alpha as it is, that is 15 degree.